So let's continue our discussion with partial fractions. Partial fractions. So this time, let's say I want to do 2x plus 1 divided by x minus 5 times 2x plus 1. This one looks a little bit complicated, and we are going to still follow the same process. All right. So what we are going to do, we are going to assume that this is equal to a over x minus 5 plus b over 2x plus 1. And that's what the assumption is. Now, what I am going to do, we are going to multiply both sides by the denominator. So it's going to be 2x plus 1 divided by x minus 5 times 2x plus 1, right? Let me leave some space there. A divided by x minus 5 plus b divided by 2x plus 1. Now I'm going to multiply both sides of the equation by x minus 5 times x 2x plus 1. X minus 5 times 2x plus 1. X minus 5 times 2x plus 1. Here, why did I do that? This and this is going to cancel. That's going to leave you behind with 2x plus 1 on the left, and on the right, there will be some cancellations. This and this x minus 5 cancel out, and that leaves you with a times 2x plus 1 plus 2x plus 1, 2x plus 1 cancel out. That leaves you with b times x minus 5. Now we are just going to simplify. So 2x plus 1 is equal to, using distributive property, I'm going to have 2a times x plus a times 1 is just a, plus b times x is bx, b times negative 5 is negative 5b. Now on the right hand side, we are going to combine the terms that have x in it. So if I factor out the terms with x, so it's going to give me 2a plus b times x plus, put it inside parentheses so that it looks nicer. Now you can see and make comparison. Now, as I said before, the equations tell you, okay? Equations tell you that what is on the left is equal to what is on the right. So this is a polynomial equation. So in a polynomial equation, sort of the polynomial coefficients match on the right and left. So that sounds a bit more academic talk. So let's make it simple. So what I want to say is that the constant on the left will be equal to constant on the right. Remember, those a and b are constants, some fixed numbers. Constant means some fixed numbers. It doesn't change. So on the left, you have 1, the constant. This is not a constant because it has a variable x in it. So, and this is not a constant either because it has a variable x in it. So the constant on the left must be equal to constant on the right. So that tells me right away a minus 5b is equal to 1. Now, the coefficient of x on the left is 2a, okay? 2a plus b. And coefficient on, coefficient, did I say left? I meant to say right. Coefficient on the right for x is 2a plus b. And coefficient on the left for x is just 2. So it must be the case, it is 2. Now you see, you have two unknowns and two equations. You can easily solve it. Easy way to solve it is this. Look, there is a 5b there, negative. So just take the second equation and multiply it by 5. That's going to give you 10a plus 5b is equal to 10. I took this equation and multiplied it by 10. Sorry, I meant 5. Multiplied both sides by 5. So now you have 10a plus 5b is equal to 10. And this top equation has a minus 5b is equal to 1. Do you see? So 10a plus a is 11a is equal to 10 plus 1 is 11, right? Now you divide both sides by 11. That gives you a is equal to 1. Nice. It came out to be a nice number. I didn't expect it to be a nice number. So, I mean, an integer. It could have been a fraction. Now that I know a, b becomes easy, right? You just plug it into one of the equations. It could be this or that. It doesn't matter. So let's use the top one. A minus 5b is equal to 1. A is 1, right? Minus 5b is equal to 1. Okay. B is 0. That cannot be true. I must have made a mistake somewhere. Did I make a mistake? Let me see. Interesting. Let's try the other one. 2a plus b is equal to 2. Yeah, b is coming out to be 0. If b is 0, duh, it should be 0. I didn't realize this. Okay, but that's okay. B is 0. I'll tell you. I'm like, what happened? B should be 0. Yes. Did you? Does anybody know what happened here? That's kind of funny. Anybody sees it? Nayeli, do you see what happened? Why is B 0?
No, I'm kind of confused too.
Anybody else sees it? Michael, do you see why B is 0?
I mean, is it because it's like being divided by the same thing, like the equation?
What do you mean?
Like it's being divided by 2x plus 1, even though it's equal to 2x plus 1?
What do you mean? Where are we on the screen? Can you clarify that?
I'm just looking at what b is on top of. I don't know if that's the reason. I just assume.
Which one? Just tell me so that I can actually see where you are.
I'm just looking at the very beginning and just seeing that b is being divided by the
B,
same. Like I don't know.
Are you
I
talking
was
about
just
this?
about what?
Are you talking about this? Where where I'm pointing to?
No, I was just looking at the 2x plus 1 that it's on top of, and I just was noticing
Here,
it's on.
here.
Yeah, yeah.
What's the problem here?
I don't know. I just seen that it's divided by the exact same thing. I have no clue why it would be 0.
Exactly. That is the reason.
Oh.
That's exactly the reason, Michael. Thank you. What happens? See, look, this and this is supposed to cancel out, right? If it cancels out, what is left? This becomes 1 over x minus 5, correct? So that means A is 1, there is no B because B should be 0, right? So that's exactly what we got. When I made the problem, I made it on the fly and I didn't realize that I put the same thing on the top and the bottom. But in sort of like hindsight, it's better. This kind of gives you, this is a new example. Typically, I don't do in the class, but by mistake, it showed up, but it is for good. It turns out to be a good thing. So this shows you that, you know, just because it reduces to 1 over x minus 5, right? So a should be 1, which you got a 1, and b should be what? 0, right? In that case, if it is 0, this term is going to vanish. You'll be left with just this. But the process is exactly the same. Is this clear? Does it make sense, Nayeli?
Yes.
How about others? Michael, make sense?
Yeah, I think I see what you're saying because it got eliminated by itself.
Yeah, it got canceled. Yeah. Mariana,
Yes.
is it clear?
Kinda, yeah.
Sure or no?
Yes, I'm sure.
Okay. All right. So let's do another problem that we kind of, this time I'll make sure that it doesn't become the same. So let's pick negative 3x plus 2 divided by 5x plus 7. So I'm making it a little bit complicated, times 4x minus 3. All right. So we are going to assume that this is going to be a. So this time a is going to be fraction, very likely. A over x plus 7 plus b over 4x minus 3. Now nothing cancels here, so it should be, we should have a single value for a and single value for b. So we are going to just write it out again, negative 3x plus 2, 5x plus 7 times 4x minus 3 is equal to a times x plus 7 plus b, sorry, not a times, a over x plus 7, b over 4x minus 3. Now what I'm going to do, I'm going to go ahead and multiply both sides by the denominator. So which is what? 5x plus 7 times 4x minus 3, 5x plus 7 times 4x minus 3, 5x plus 7 times 4x minus 3. All right. So these two and these two are going to cancel in the left. That's going to leave you with negative 3x plus 2 is equal to, now x, I forgot something, it's 5x, sorry, it's 5x in the bottom. So 5x plus 7, 5x plus 7 cancel out. That leaves you with a times 4x minus 3. 4x minus 3 and 4x minus 3 cancels out. That gives you b times 5x plus 7. Okay. Now, what you want to do is simplify it. Negative 3x plus 2 is equal to, using distributive property, is going to be 4a times x. A times negative 3 is negative 3a plus b times 5x is 5b times x. B times 7 is 7b. So negative 3x plus 2 is equal to, I'm going to combine the terms that have x in them, which is 4a plus 5b times x, then plus 7b minus 3a. Okay, I'm just combining this and this. 7b plus minus 3a. Now I'm going to look at the coefficients and constants. Constant on the left is 2, constant on the right is this. So which is negative 3a plus 7b must be equal to 2. Coefficient on the left is negative 3. Coefficient on the right is 4a plus 5b. Coefficient of x on the left is negative 3. coefficient of x on the right is 4a plus 5b. 4a plus 5b must be equal to the coefficient on the left, which is -3. Now you just need to solve this equation. So you use the elimination method. So let's eliminate a. So 3 and 4. So I'm going to take this equation, multiply it by 4. Take this equation, multiply it by 3. So 4 times -3 is -12 times a, plus 4 times 7b is 28b, is equal to 4 times 2 is 8. So just keep in mind, I'm multiplying this by this, this by this, and this by this. Similarly, for 3, use 3 to multiply both sides of this equation. 4a times 3 is 12a. 5b times 3 is 15b, is equal to -3 times 3 is -9. I'm going to add these two equations. Then positive 12a and negative 12a, they're going to cancel. 28 plus 15 is 43. 43b is equal to 8 plus -9 is -1. So if you divide both sides by 43, you get b is equal to -1 over 43. That's your b. Now you need to find a. So just take one of the original equations. 4a plus 5b is equal to -3. 4a is equal to -3 minus 5b. I subtract 5b from both sides. 4a is equal to -3 minus 5 times -1 over 43. That's going to give you 4a is equal to -3. Negative times negative is going to be positive, 5 over 43. Then 4a is equal to -3 times 43 over 43. I'm making the same denominator or common denominator, 43. So 4a is equal to, so -3 times 43 is -9, 129 plus 5 over 43, or 4a is equal to -124 over 43. Then divide both sides by 4, divide it by 4. That gives you a on the left is going to be -124 divided by 43 times 4. Now 4 goes into 124 31 times. So that's going to give you a is equal to -31 over 43. So let me write it down. A is equal to -31 over 43, and B is equal to -1 over 43. And by the way, that's what your answer is. All right. A is going to be here and B is going to be here. So if you break this down, you're going to get these two fractions. So instead of writing A, you're going to write -31 over 43. Instead of writing B, you're going to write -1 over 43. And if you want, you can bring the 43 down here and write it like this: -31 over 43 times 5x plus 7 minus 1 over 43 times 4x minus 3. And if you simplify it, you're going to get this. Is this okay, guys? Do you feel okay with this problem?
Yeah.
I think so.
Yes.
So in the exam, what I might give you is a problem like this, and I might ask you what is A and what is B. Okay, you will have to do the problem and then find out what the actual value is and then plug it in. So this is how you do problems like this. Is this okay, everyone?
Yes.
Okay, I'm going to give you yet one more example of this type, okay, so that you feel confident about it. So yes, this is an example. Negative 4x plus 3 over 2x minus 7 times 3x plus 1. All right, we want to make it a partial fraction, so I'm going to leave this blank. So you want to write it as something over 2x minus 7 plus something else over 3x plus 1, and we are going to find the somethings. Okay, so we assume negative 4x plus 3 divided by 2x minus 7 times 3x plus 1, that is equal to a over 2x minus 7 plus b over 3x plus 1. Let's put it inside parentheses. Now we are going to have to multiply by something. What is that something? Can you help me out? Multiply both sides by which terms?
Can you
Sorry,
repeat again?
yeah. Well, basically, I was gonna say the same thing. Just the 2x minus 7 and the 3x plus 1.
Exactly, 2x minus 7 times 3x plus 1. 2x minus 7 times 3x plus 1. 2x minus 7 times 3x plus 1. Now this cancel out. That gives you negative 4x plus 3 is equal to 2x minus 7, 2x minus 7 cancel out. That gives you a times 3x plus 1 plus 3x plus 1, 3x plus 1 cancel out. That gives you b times 2x minus 7. Okay, b times 2x minus 7. Now the problems become easy. Negative 4x plus 3 is equal to, using distributive property, 3a times x plus 1 times a is a plus b times 2x is 2b x times b times negative 7 is negative 7b. Negative 4x plus 3 is equal to 3a plus 2b times x plus a minus 7b. All right. Now you compare the coefficients. You compare the coefficients. So coefficient of x is negative 4. Coefficient of x is 3a plus 2b. So 3a plus 2b is going to be negative 4. And then a minus 7b is equal to 3. A minus 7b is equal to 3. Easy way to solve it is just you can solve for a, That's gonna give you 3 plus 7b, right? I'm adding 7b to both sides in the second equation. In the second equation, I'm adding 7b to both sides. So that gives you a is equal to 3 plus 7b. Now take this a and plug it into the other equation, not this equation, not the one you solved, not that one, okay? The other equation. So it's gonna be 3a plus 2b is equal to negative 4, right? 3 times a, but instead of a, I'm gonna put 3 plus 7b. The method I'm using is called substitution method. You have seen it before. Plus 2b is equal to negative 4. So 3 times 3 is 9. 3 times 7b is 21b plus 2b is equal to negative 4. 9. 21 plus 2 is 23b is equal to negative 4, right? Subtract 9 from both sides. So 23b is equal to negative 4 plus negative 9 is negative 13, or b, divide both sides by 23 is negative 13 over 23. So that's your b. So you're going to put for b negative 13 over 23. Now let's find a. A is equal to, we just solved for a here, 3 plus 7b, right? So a is 3 plus 7 times b is negative 13 over 23, or a is equal to 3 plus 7 times negative 13 is negative 91 over 23, or a is equal to 3 times 23 over 23, okay? Because I want to make the common denominator, and this negative times positive is going to be negative 91 over 23. That is going to give me a is equal to 3 times 23 is 69, I believe, divided by minus 91 divided by 23. So a is equal to, so 70, 20, 22. So it's going to be negative 22 over 23. And that is your a. So it's going to be negative 22 over 23. Now, of course, as I said, if you want, you can rewrite it slightly differently. Take this negative 22 over 23 and take this as well off, right? That's 23. And that is how you will do these problems, these partial fractions. Is this example clear to you? Can you do similar problems if you're given?
Yeah, I think so.
Everybody? Do you
Yeah.
have?
Yeah.
Okay, good. I'm recording it so you can watch it too. So I'll send you the recording. All right.
Okay, we'll get it through Gmail or what? Or how do we see it?
Hartnell Gmail. Hartnell Gmail.
Okay.
Okay.
Sounds good. Yeah.
Now I'm gonna do yet another example of partial fraction. So this is slightly different. So this time you have, let's say, x squared. Let's make it 3x squared minus 2x plus 1 divided by, so this is a bit complex, 4x plus 7 times 2x minus 1. Okay. We want to write it as something over 4x plus 7 plus something else over 2x minus 1. Now this one is a little tricky. Why is it tricky? You have a square term here, right? X squared. So if you have something like this is what you have to do. So 3x squared minus 2x plus 1 divided by 4x plus 7. Okay. Just on a second thought, I'm realizing that it could get a bit messy in terms of calculation because we will have 4 equations. I'll try it. If it gets too messy, I'll skip it. How does that sound? Is it okay? Okay, 2x minus 1. This is going to be equal to a, so let's write down in the bottom, 4x plus 7 is going to be ax plus b. Okay. Now, why am I writing ax here? Because of this square term. Plus cx plus d divided by 2x minus 1. And whenever you have the same term, same power on the numerator as it is in the denominator, then you have to structure it like this. Look, there is a square term on the top, right? Right here, square term. But in the bottom, there is a square term too. If you multiply it out, you'll see 4x times 2x is actually 8x squared. So you could technically do a division. Okay, so I think I made the problem too hard. So I'm just not gonna do it because if you have the same power, you could do a division and then do partial fraction. So just change the problem a little bit, okay? Just a little bit. Because you can do it, but it becomes slightly harder. So I'm just gonna take it off, just the square part. Now that's gonna give me something nicer. Okay. All right. I'm gonna write it as a over 4x plus 7 and b over 2x minus 1. But I'm still tempted to give you an example with square, but let's just do this and have you feel comfortable. I think I'll be happy with that. All right, so let's go ahead and simplify it. Again, the same thing. We are going to multiply both sides by both top and the bottom by 4x plus 7 times 2x minus 1. I mean both sides, not top and bottom. Both sides by this 4x plus 7 times 2x minus 1. 4x plus 7 times 2x minus 1. This, all 4 of them cancel. That gives you negative 2x plus 1 is equal to 4x plus 7. 4x plus 7 cancel out. That gives you a times 2x minus 1 plus b times 2x minus 1. 2x minus 1 cancel out. That gives you 4x plus 7. Now, I'm gonna do it quickly. 2x plus 1 is equal to, I'm just gonna save time because you have seen it before. 4b times x plus 7b minus a. Okay, and that's gonna give you negative a plus 7b is equal to 1, and 2a plus 4b is equal to 2a plus 4b equal to negative 2. this coefficient with this coefficient and this with this. And I can divide this guy by 2. That's going to give me a plus 2b is equal to -1. And then add that to the other equation, -a plus 7b is equal to 1, right? Okay. And that is going to give you, and I ran into another problem of the same type, the very first one, since I'm making the problems on the fly. It's kind of funny in the same day, two problems of the same type. Okay, but now you know what it is. So 9b is equal to 0 or b is equal to 0. So a is, what is my a? Oh, I haven't found a. So negative a, negative a plus 7b is equal to 1, and b is equal to 0 means negative a plus 7 times 0 is equal to 1, or negative a is equal to 1, or a is equal to -1. So a is going to be -1 and b is going to be 0. Now, why is b 0? Look, for some reason, negative 2x plus 1 and 2x minus 1. Isn't it the same thing as negative 2x minus 1 divided by 4x plus 7 times 2x minus 1? Do you see? Then this and this cancel out. That gives you -1 over 4x plus 7. It becomes, you can reduce it to a single one, right? Single fraction. So look, that's why you get -1 over 4x plus 7 and 0 over this, which makes this 0. These examples, I like them. I never did this silly and trivial examples, but it's kind of interesting to watch it. So you get the main idea, right? So I might give you yet another example for partial fractions. Maybe I'll give it to you in the next class. So I want you to observe the materials, simple ones, the ones I just did. Do some practice and watch the video and whatnot. And then on Wednesday, I'll give you another example, which will be slightly higher, okay, slightly more difficult, but not too much. Conceptually is the same, but slightly more difficult. Any question, anybody, before I move on?
No.
Everybody okay with this type of partial fractions? You can do it in the homework and in the final exam?
I think so. Seems pretty
Yeah.
good.
Cool. All right. Now I'm gonna do something called Gauss-Jordan elimination. Gauss-Jordan method. This is another way of solving a system of linear equations. So let's give you this. This is gonna be 7, I think. Let me just check it quickly. Actually, 5. I can put any number I want, but I just want to make it a little simple for you guys. Okay. Oops, I'll change it here again. Okay, now it will be easier. All right, I want you to solve this system of equations. All of you know how to do it, right? You guys have solved it before. you have solved it using the substitution method and elimination method. And I have used the substitution and elimination method even in today's lecture with two different problems. I used both of these methods, and you have done it in the last class, which is technically along this track is intermediate algebra. Over there, you talked about and learned about elimination and substitution method. However, we are going to solve this system using a different method called Gauss-Jordan method. And this is really cool. You have to kind of like see the beauty in it. So here is the situation. So let's say the solution to this equation, I know it because I made the problem up. Solution is 1, -2. That means your x is 1 and y is -2. That's the solution. You can plug it in here to see that that is the case. Now, if I switch the equations, bring the top one to the bottom and the bottom one to the top, that means I switch it. Write this one first and this one second. That's not going to change the solution, is it? It doesn't change the solution. Also, so I can switch them. So it's not going to change the solution. Also, I could do something else. I could multiply this equation by a non-zero number. So that let's say I do this. 2x minus 5y is equal to 12. I multiply both sides of this by 2. Then I get 4x minus 10y is equal to 24. That also doesn't change this solution. Okay, that also doesn't change this solution. Just because you multiplied it by a non-zero number. You cannot multiply by 0, then you kill the equation, right? Both sides become 0. If you multiply it by some non-zero constant, that is not going to change this solution. That means it's still going to be the same. Okay, hold on 1 second, guys. Okay, so it's not going to change it if you multiply it by a non-zero number. The same goes for the second equation too. All right. So these two are really powerful things. And then there is yet another rule, which is slightly tricky to see. Let's say I take the first equation, which is this one, multiply it by 2, and take that result and add it to the second equation, -3x plus 4y is equal to -11. So I'm going to get x, 4x minus 3x is x, -10y plus 4y is -6y is equal to 24 minus 11 is 13. Okay. These result in equivalent equations. Okay. So it's not going to change. So what I have done here, if I say x is equal to 5, then if I add 2 to both sides, that doesn't change the fact that x equal to 5, does it? No, because now I'm just going to get a newer equation, x plus 2 is equal to 5 plus 2, 7. The solution to this equation is the same as the solution to this equation. They're the same, right? So it doesn't change. That's exactly what I have done. When I have added this equation to this equation, I'm adding the same value because equation says what is on the left is the same as what is on the right. So it's like adding 2 to both sides of the equation. So this is the second equation, right? To this equation, I added this to the left and 24 to the right. This to the left, let me use a different color. This I added to the left, 4x minus 10y, I added to the left, which is also equal to 24. That's what this equation says, which I added to the right to get this new equation. It's kind of like x is equal to 5. That's your original equation. You add 2 to the left, 2 to the right. You are more used to and more comfortable doing it. That doesn't change the solution to this equation, because you could subtract 2 from both sides. You'll see x equal to 5. The original solution is the same, right? We do the exact same thing. However, we do it with a variable here. That's why you are kind of thinking, oh, is this the same? So when I say negative 3x plus 4y is equal to negative 11, if I add 2 to both sides, you're okay, right? You feel comfortable. But if I add 4x minus 10y to the left and 24 to the right, that's equivalent to, because these two things are equal. I'm adding the same thing. In an equation, you can add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same number except for 0, divide both sides by same number except 0. These are the basic properties of an equation. And once you can do it, by the way, that helps you solve an equation. So these are the 3 rules that I kind of want to touch on. Now it will become more clearer once I solve the problems. So let's get back to our original problem, which is solving these 2 set of equations. What I'm going to do, I'm going to create an x column, which we did before. I'm going to create a y column, and I'm going to create a constant column. So you have to write the equation exactly in this structure. X, y, and constant. All right. X, y, and constant on the right. X, y, and constant on the right, in that order. So what is the coefficient of x in the first equation? 2. What is the coefficient of x in the second equation? Which is negative 3. What is the coefficient of y in the first equation? Negative 5. What is the coefficient of y in the second equation? Which is 4. What is the constant on the right side of the first equation? 12. What is the constant on the right side of the second equation? Negative 11. And I just created a matrix and I put a vertical line here. This is called augmented matrix, which you have seen before. Augmented matrix. It is called augmented matrix. All right. It is augmented matrix. Any question, anybody? Augmented matrix.
No, seems pretty good.
Okay. Now look at the left side of the vertical line. This is a square matrix, okay, 2 by 2. What I'm gonna do, I'm gonna solve it or do these row operations, not solve, row operations, so that I have 1, 0, and 0, 1 on the left side. And on the right side, I could have some number A and B. And you will see that A is gonna be 1 and B is gonna be negative 2. And when you have it in this structure, it is called reduced row echelon form. Reduced row echelon form. Reduced row echelon form. So now we want to make the left, by the way, look like this. So one thing I can do, take the top equation, top row or first row, and multiply it by 1/2. Remember, you can multiply an equation by any constant other than 0 without changing. So multiplying this top row by 1/2 is kind of like multiplying the top equation by 1/2. You can think of it that way. So I'm gonna multiply the row 1 by 1/2, and I am gonna create a new row 1. So multiply the first row by 1/2, and this becomes my new row 1. Why am I doing it? So that I have the top corner 1, top left. So it's gonna be 1, -5/2, okay, and 6. Then keep the second row as it is, 3, 4, -1. Is this clear to everybody?
Yes.
Okay, now I gotta make these guys 0. And there is an easy way to do it. Take the first row, multiply it by 3. So take row 1, multiply it by 3, plus add this multiplied result to the second row, row 2, and this becomes your new row 2. And so this is a little bit tricky. Take the first row. You're not, by the way, even though you're multiplying the first row by 3, right? You're not going to replace the first row by that value. You're going to actually apply that to the second row. So let's go ahead and do that. So the first row by 3 is going to give me 3. -5 times 3 is -15/2. 3 times 6 is 18. Okay. And take this result and multiply it, but add it to the second row. The second row is -3, 4, and -1. If you do that, this becomes 0, and 2/2, 8. This becomes -7/2. Okay, and this becomes 17. So now your new thing becomes 1, -5/2, 6, and the second row becomes 0, -7/2, and 17. So good. I got the first column taken care of. Look at the first column here, which looks exactly like this. Now I gotta make this guy a 1, which I can do easily. Multiply the second row by the reciprocal of that, which is -2/7. Times row 2 becomes your new row 2. Row 1 stays the same, 1, -5/2, and 6, and 0 times this is 0. Now, -2/7 times -7/2 is, by the way, 1. Okay, -2/7 times 17, -2/7 times 17 is -34/7. So this is going to be -34/7. By the way, it's very easy to make mistakes in these calculations. So be patient if I make mistakes. So let's just erase some of this stuff so that I have more space. Okay. Now, I'm going to take this guy and move it up. Right? So I want to make this 0. You can do that by doing the following. Take this second row, multiply it by 5/2, and add it to the first row. Don't do anything to the second row. It stays as it is, 0, 1, and looks like I made a mistake already. I'm finding it out, okay? For some reason, I made a mistake. Where did I make the mistake? So let me just quickly check it. Oh, duh. That's why. Do you guys see it? I made a mistake a long time ago. Let me use red so that you can see it. I put -1. What was it? 11. No wonder why. So I just have to erase it and do it over. Okay, so bear with me. So I'm going to just erase these guys and just do it again. You'll see, you'll make mistakes. So this is very common to make mistakes if you do it manually. This process is extremely useful for computers, by the way. Okay, computers can do this kind of calculations very quickly. When you have more than 2 equations, hundreds of equations, manually you could solve it in theory, but likely to make mistakes, and it's not productive use of your time. So let me create the thing again. It's gonna be 2, -5, 12, -3, 4, and -11. Let me double check. 2, -5, 12, -3, 4, and so sure. Now just multiply the first row by 1/2. 1/2 times row 1 becomes my new row 1, right? So that gives me 1, -5/2. Then why did I write 12? My Jesus. Okay, it's 12. Okay, and that is 6. Okay, so that's my first row, and the second row stays the same. -3, 4, -11. All right. So that's what it is. Now I'm going to take the top row, multiply it by 3, and add it to the second row. Okay, why am I doing it? Because I want to eliminate this -3. So it's going to give me my new row 2. So I'm just going to write the first row as it is, -5/2, 6. And the second row, I'm just going to do it here in the bottom. So 3 times row 1 is 3. 3 times -5/2 is -15/2. 3 times 6 is 18. And then add it to the second row, -3, 4, and -11. So if you add these two, you're going to get 0. So this and this cancel out. This is going to give you -7/2. Okay. And this is going to give you 7. Okay. So that's your matrix, augmented matrix at this time. Now you want to make this number a 1. You can do it very easily if you take row 2 and multiply it by the reciprocal of -7/2, which is going to be -2/7. That becomes your new row 2. All right. So row 1 stays the same, -5/2, 6. And row 2 becomes 0 times -7/2 is 0. 0 times -2/7 is 0. Then -7/2 times -2/7 is 1. -2/7 times 7 is -2. Okay. Now you want to make this guy a 0. You can multiply the second row by 5/2. So 5/2 plus times row 2 plus row 1 becomes your new row 1. So this one requires a little bit of work. So 5/2 times second row is 0 times 5/2 is 0. 1 times 5/2 is 5/2. And then -2 times 5/2 is -5. And I'm gonna add this to the first row, 1, -5/2, and 6. If you add this, okay, this becomes 1, 0, and 1. So that your new row 1 becomes this 1, 0, 1. Then that's your row 1. Oops. That's your row 1. Okay. And then row 2 is this. We didn't do anything to it. 0, 1, -2. Now look, this was your X value, this was your Y value, this was your constant we talked about. Now let's look at the second row that tells you 0 times X plus 1 times Y is equal to -2, which is to say Y is equal to -2. And your top row tells you 1 times X plus 0 times Y is equal to 1, or X is equal to 1. Look, X is 1, Y is -2. X is 1, Y is -2. And that is what we were expecting. You see that? This is called Gauss-Jordan method. So on Wednesday, I'm gonna do this again because it's very, very easy to make mistakes with these problems. And I'm gonna go ahead and do at least 3 more examples, of this type, okay? How to use row operations to solve a system of linear equations. Now, one very interesting thing here, there is not a unique way of solving or going through these row operations, okay? So that's very important to keep in mind. There is no unique way to go through these row operations. You can do it in your own way, so long you follow those 3 rules. You can switch 2 rows, you can multiply any row by any number other than 0, or you can multiply any row by any number other than 0, actually including 0, and add it to another row. Okay, so let's keep it simple. Just don't multiply by 0 at all. Okay, you can multiply any row by any non-zero number, fixed non-zero numbers, or you can multiply any row by fixed non-zero number and take that result and add it to another row. All right, that's what you can do. This should do it. I think we'll call it a day. Any question, anybody on this?
I'm all good.
Is it hard, or are you following along this Gauss-Jordan method?
I think it's somewhat hard and easy at the same time. It's just a matter of practice, I guess.
Yeah. So I'll give you some practice problems. Do these problems on your own. So I'm just making it up right now. 2x. So write it down, everybody. Okay. 2x minus 7y is equal to 9. And 3x. Actually, not 3x. X minus 2y is equal to 3. This is one problem. Practice it. Okay. Number 2, 4x plus y is equal to 9. Negative 2x plus y is equal to 3. Okay. Yeah, I think, and I'll give you another one. Negative 5x plus 4y is equal to negative 1, and 2x plus 3y is equal to 5. I want you to practice all 5 problems using the Gauss-Jordan method. You can watch the video and see how I'm going through the steps. Okay, practice these 3 problems, and on Wednesday I'm gonna do similar problems. Okay, and just to give you a hint, for all of these problems, the answers are going to be integers. Okay, X and Y values are all integers. I made it in such a way so that X and Y comes out to be nice number, no fractions, right? So make sure that you do it properly. Okay, let me just double check. Okay, so this is just a little change. This make this -3. Okay. So -2x plus y is -3. Okay. All right, then. Okay. 1, 2, 3, 4, 5. Okay. Let's just double check this one too. I'm just trying to make sure that it comes out to be as integer. Oh, it is right. Okay, all the answers should be integers. Okay, all these x and y pairs that you're gonna get, one xy pair here, one xy pair here, one xy pair here, is gonna be all integer values. So please try these problems and practice this. It's a little bit hard at the beginning when you are trying to learn this method, but it's not really complex. Someone said it's kind of hard, but at the same time it's easy. I like that expression. Yeah, it is kind of hard, but at the same time it's easy. You just have to kind of do a few problems. Sit down and try these problems. And maybe I'll give you, here is another problem you can try. Maybe 2 more. 2x plus 1 over 3x minus 7 times 2x plus 3. Do the partial fraction for it. And then 4x minus 2, no, let's make it 1 divided by 5x plus 3 times 2x plus 1. So this is your homework. Do these 5 problems. If you can solve them, you will have a good grasp of the topics that we talked about. All right. And I have given you the tools to do all of these problems. Any question, anybody?
No, none at all.
All right. If you don't have anything else, that's all for the day. And I'll talk to you guys on Wednesday at 8 o'clock. Please try these 5 problems in between and come prepared for classes on Wednesday. And I'll send you the video of this lecture. Thank you so very much. Have a wonderful day.
You too.
Thank you.
All right, you too.
Take care.